Right. Okay. Okay. So let's begin. I'm going to share my screen to kind of give you an idea of what it's about. Let me start sharing. Okay. So let me just create a new one to kind of give you some context. Okay. So last week, let me check if I unmuted. I did. Okay. So last week, what I showed you was how to take a variable that's normally distributed. So for instance, we had some variable which we'll call x. Okay, we had some variable x, right? And it follows a normal distribution. So that means here's the graph of its distribution. Okay. That it's centered at some value, mu, the mean. Okay, and what we did was, if we want to find out any probabilities regarding x, so for instance, if you want to know the probability of x greater than 100, for instance, then what we would need to do is we would need to convert it to a z. Okay, so we'd convert it to z, and how we do that is we use this formula. Sigma. Okay. All right, and then once you do that, then you can use this distribution, which is in the back of your book, your textbook that is, which has a table that can assist you in finding these probabilities. Now you've converted x to z. You're no longer dealing with x on the horizontal axis, it's z, because you use this formula here to go from x to z, and now you can find the probability that you're looking for. Right, that's kind of the process what we covered last week. So x is some random variable. Now x could be, let's say for instance, you've got a factory that makes batteries. Okay, so this factory, this is the plant, it makes batteries in it. So let's call this first battery x1. Then there's another battery that they make x2, and so on and so on. Let's say they go up to, let's say, 1,000 batteries. Right? We're just looking maybe just in a day or something. Okay, so they make about 1,000 batteries. So each one of these is thought of as an x. Right? So if you want to know the probability of battery 1, that is x1, being greater than 100, then you would follow this process that we're doing here. Follow this process, convert to z, get the probability. Same thing for x2, all the way till x,000. Now, x1 is probably, you could think of it, for this example, it's just the battery lifetime. So, for example, what is the chance that the lifetime of battery 1 is greater than 2 years? Right? And if you want to know what's the probability of the 1,000th battery, the last one that's made, what's the probability of the 1,000th battery greater than 1.5 years? And you can work out these probabilities by using this transformation, right? So in general, instead of x1 and x,000, we, instead of writing it for each specific battery, it doesn't matter which one, because for all of them, you would use the same z formula to find the probabilities, right? So in general, you don't have to subscript it. Just think of it as a battery in general. Okay, so it's very important you understand that. Okay, so everyone understand what I just said now? This example with the battery lifetimes. If you're not sure, please let me know. Okay, all right, so this is the factory that makes, let's say, 1,000 batteries, okay? Now, like I mentioned with x, x is just the lifetime of a battery, of a single battery, okay? Now, what you could do is, instead of just looking at one specific battery, let's say now, in that same plant, instead of looking at one specific battery, what you're going to do is you're going to take a sample of them. Instead of looking at all 1,000 of them, you could have, for instance, X1 in the sample. You could have X5 in the sample, all the way till maybe randomly you're choosing batteries. Let's call this one X60. Let's see, you randomly choose these batteries. So not every battery makes it into the sample. So out of the sample, you have the X2, battery 2, battery 3, battery 4, etc. Okay, because you wouldn't have X5 because X5 made it into the sample here. So maybe let's use a different color here. So the sample is the selection in blue. We just gathered, say, 50 batteries here. Okay, so this sample contains 50 batteries. Okay, now if we have 50 batteries in them, right, we can get an average for those 50 batteries. Okay, so think about it. If battery 1 lasts 2 years, battery 2 lasts 3 years, and battery 4, let me just give you an example of 3 batteries, right? So you go with battery 1, it lasts 2 years. Battery 2 lasts, say, 2.5 years, right? And then battery 3, if I just have 3 batteries, right, it lasts about 1 year. I can get an average for these 3 batteries, right? Okay, the average would be 1 plus 2.5 plus 2, and I divide it by 3. That would give me the average lifetime for all 3 of them. So in the exact same way, I can get an average for these 50 batteries. I would add up the 50 batteries lifetimes, and I would divide by 50. All right, so that average, we would represent it by some symbol called X bar. Okay, it's important to understand the symbol. This is the average of the sample. Okay, this is the sample we took, and if we want the average of that sample, we will represent it by X bar. Okay, so it's important that I'm bringing this notation up because we're going to use it now. All right, so keep in mind, X bar is the average of the sample, right? And X, the big X values, is just a single unit. That means it's just one battery. Okay, now if we're talking about the average of the sample, and if we want to know the probabilities for the average of the sample, for instance, what is the chance, okay, that the sample, the average lifetime of the sample is greater than some value, right? Say 5 years, for instance, right? We need to use the same distribution here to find it. We need to use the Z distribution to find it. Okay, the table is in the back of your book. Okay, now the difference between what we've done here on the left is how we go from X bar, okay, how we go from X bar to Z. So how do we go from X? So we start with X bar now. How do we go from X bar to make it a Z value so we can use the table in the book? And that's what I'm going to cover now. All right, so let me just clear this part out here so I give you some context. Okay, almost done. Okay, so what I've shown you so far on the left, okay, that's if we have a single unit. That means just keep thinking about this battery as an example, okay? We have a single unit that we're looking at, and this is how we go from that single unit X to Z. Now, when you're working with the sample mean, all right, you also want to convert it to Z, but the process and how you do it is different, okay? And I'm going to show you how it's done, all right? So now, instead of starting off with X, we are starting off with the sample mean. And now it's X bar on this axis, right? And we want to go from X bar to Z. And the formula you use to do that, which you don't need to memorize, it's in your formula sheet, is Z equals X bar minus mu all over sigma. Right? We use that formula, and that formula will convert it to Z, and then we're back to what's familiar with to us, like what we did last week, is using the table in the back of your book to find the probabilities. So let me draw the Z curve. All right. So the takeaway right now, what I just discussed, is when you have a single unit that is X and you want to convert it to Z, use this formula here. However, you need to identify if the question is not asking you for a single unit. If the question instead is asking you for the sample mean, which is X bar, then you need to use this formula to go from X bar to Z. All right. So let me show you how it's done with an example to kind of put things into context. All right, let's look at the typical kind of problem you'll be presented with. Let's focus on the problem on the left in the left box. Okay, so we'll come to the right box in a second. But now, I'm just going to draw your attention to the problem on the left, this box here. Okay, all right. The question says the mean lifespan of a brand name tire is 50,000 miles. Okay, assume that the lifespans of the tires are normally distributed and the population standard deviation is 800 miles. So let's start writing out the symbols for the values that they're giving us in the question. I say they're saying the mean lifespan, so the mean lifespan here of a brand of tire is 50,000 miles. In other words, mu is 50,000. Okay. Assume that the lifespans are normally distributed and that the population standard deviation is 800 miles. So your population standard deviation is 800 miles. In other words, the symbol for that is sigma. And sigma is 800. All right. If you select one tire, okay, a single tire, single unit, what is the probability that its lifespan is less than 4,800 miles? Okay, so what they're asking you for question A is you taking a single tire, one tire, and you want to know what the chance is of that tire having a lifespan of less than 48,500 miles. So X is the lifespan of a single tire. So X, this is the lifespan of a single tire. Single tire. All right. And they're asking you to find the probability that that lifespan of that tire is less than, or 48,500 miles. Okay. Let me just check the chat. Any questions? Good. Okay. All right. So coming back to that. Okay. So this we're familiar with because this is what we did last week. Okay. We need to use the table in the back of our book to solve this. But before we do that, we need to convert the X to a Z. So what they're asking us here, this is, if I just sketch the diagram, and I encourage you to sketch it. Okay. If I sketch it, let's say here, this is X, and it has an average. There's your average here. Center that 50,000. Okay, so it means peaks at that 50,000, then it dips again. Okay, so there's 50,000 at the center, and they want us to work out what is the chance that X is less than 48,500. Now, 48,000 is on the left of 50,000 because it's lower than 50,000. So I'll sketch it here. It doesn't have to be accurate. You just need to have an idea whether it's on the left or the right of the center. So it's here, 48,500. Okay, so there's that vertical line that cuts it off. And we are looking for the area where x is less than 48,500. So less than 48,500 means everything on the left of it. So we need to find this area here. Okay? If you find this area, then that's the answer, because the probability is just the area under the curve for whichever region you're looking at. And for us, the region we're looking at is the area on the left of 48,500. Okay, so how do we solve this? Well, we convert it to a z value, and we use that formula z equals x minus mu over sigma, which we did last week. So we're going to convert this to a z curve, all right? So if we do that, and I'll sketch this on the left. Okay, so now it's in terms of z. Z is centered at 0. Okay, this 48,000 now is equivalent, if I use this formula here, where I put 48,500 for x. For mu, I put 50,000. And for the denominator sigma, I substitute 800. I substitute those values, then this 48,500 becomes, I'll tell you now, it becomes minus 1.88. Minus 1.88. And remember, we're looking for the area on the left of it. And so I won't go over how to find this area, this probability on your table, because we've done this last week. I'll just write the answer out here, and you can do this as an exercise. Okay, so I covered this last week. So pretty much what I've done here so far is nothing new to what I've done last week. Okay, so this answer, this area is 3.01%. 3.01%. All right, so the answer to this problem for question 1 is 3.01%. 3.01%. That's the answer. Okay, so that's question A, right? Now question B is Learning Unit 7. Okay, and I'm going to explain the difference to you now. This is the new content. All right, so far what I've done is nothing what you haven't seen before, because we've covered this last week. Question B, however, is different. All right, so now I'm going to just remove this, and then we're going to tackle question B. All right, I'm there. Cool. All right, so now let's do question B. Question B. All right. Okay, now question B says if you select 100 tires. Okay, so now you're selecting 100 tires. So you're taking a sample, okay? Just like I showed you earlier, now you're just taking a sample of tires. Before I used batteries, now I'm using tires in this question. So you have a sample of 100 tires. Here, there's X1, tire 1, tire 2, etc., all the way to the 100 tire. So in the sample, you have 100 tires, okay? And this 100 tires would have an average lifespan, okay? So X bar will be the average, that sample. So this question is asking you, what is the probability that the average, or in other words, mean lifespan of that sample is more than 50,200? So question B is asking you this. If I have to write it out mathematically, it's this: X bar greater than, because it says more than 50,200. So this is what they're asking you. So just like what we did earlier, we need to convert that X bar to a Z value. So in other words, this is what they're asking us. visually to solve. Okay, you've got this distribution of x bar. Okay, so now it's x bar on this axis. Okay, 50,200, so there's 50,200 here. 50,200. And they want you to find the area for everything on the right to 50,200. So you need to find this area here. Okay, and that's the answer to this problem. If you find this area, that is the answer. All right. However, we don't have a table for the lifespan of tires. Okay, so what we have to do is we have to convert it to a Z variable, which we do have a table for. And how we convert it to Z is, like I told you earlier, is we're using this formula here. Z equals x bar minus mu all over sigma over square root of n. That is the formula we use to convert x bar to Z. Okay, this formula is in your worksheet because you don't need to memorize it. Okay, we're going to use this formula here. All right, so in other words, if you use that formula, give me a second. Let's get to that. Z, this is the curve for Z. All right, and it's going to be a value here. We're going to figure out what that Z value is, and we need to find that area on the right of it. And we're going to figure this out by using this formula here. All right, so let's use this formula now. So the formula, I'm just going to write it out a bit bigger. We're going to use this formula. Z equals x bar minus mu all over sigma over square root of n. This is the formula we use. Okay, you don't need to memorize it. You just need to know how to use it. It is given to you in your formula sheet. All right. Now, so let's enter everything in our calculator. All right. So here, for x bar, you're going to put 50,200 because that's the value they're telling you to convert to a Z. It's going to be 50,200 minus mu, which is given to us here. There it is, 50,000. All over sigma, which is 800, given to us. Divided by square root of n. Now, what is n? N is in the question. It tells you how many tires you're selecting, your sample size. It's 100. Your n is 100. So it's a square root of 100. All right. That's what you're going to punch in your calculator. And if you do that, you'll get a Z value of 2.5. Okay, this becomes 2.5. 2.5. So in other words, this question mark here, the Z value here is 2.5. I remove this. That is 2.5. All right, that's your Z value. So we want to know the area on the right of 2.5, which we would use the table in the back of our book to solve. And if you do that, you'll find that this area here, the answer is 0.62%, 0.62%. Okay. Everyone understand? Any questions? X bar 1. No, Taylor, X bar is not a value. It's not a fixed value. It's a variable. 100 is just a sample size. Okay, so when it's a variable, what you're trying to work out is the probability of that variable being greater than something or less than something. Just like x, just like, see the problem on the left with a, you don't know what x is, okay? X is not a specific value, it's a variable. But what we do is we try and find probabilities of x, okay? That variable of a single tire. So if we want to know the probability of any tire being less than 48,500, then we would follow this process. Now, x bar is also a variable. Now remember, if I draw a sample of 100, the sample won't necessarily be the same if you draw the sample. You could draw a sample of 100 from the factory, and we'll call your sample x bar t, right, for your name, right? I draw a sample. I can also draw 100 tires, but it may not be the same 100 tires that you draw. So I'll call my sample x bar d. So both of our samples of tires has 100, but it's not necessarily the same 100 tires. Everyone in this chat can draw a sample of 100 tires, okay, and so on. But the 100 tires won't necessarily be the same. So what we want is we want to be able to derive probabilities for any sample, mine, yours, anyone else in the chat, of a size of 100, and determine what the probability, what's the chance of the average of that sample being greater than something or less than something. In our case, what's the chance of that sample being greater than 50,200? Does that make sense? Everyone? Then does it make sense? Does it answer it? Or do you want me to repeat that? Or say it another way? Okay. Okay. 100 is just the size of that sample. Okay, so remember, you drew a sample of 100 tires. I drew a sample of 100 tires. There could be another person C, that draws a sample size of 100. But our samples will be different. You don't have to necessarily, you could have 100 tires, but it's not necessarily the same 100 tires that I have. And tires that I have may not be the same 100 tires that person C has. But in general, instead of writing, okay, if I want to know what's the chance of the average of your sample, the tires that you choose, being greater than 50,200. Okay, that would be the same, that probability that for your sample would be the same as mine. Probability of A x bar D greater than 50,200. And it would be the same for person C as well. Probability of x bar, you get the point. 200. Okay, so it applies to all of our samples. That's what you're doing. Okay, you're not working out for a specific sample. For any sample of the same size, the probability would be the same. Okay. N is 100. Yes, Vanessa, that is correct. X bar is the average. Yes, X bar is the average. Okay, so instead of, let me just clear this part out. Let me clear this part out. Okay, so the thing is, Talon may draw 100 tires, right? He's got 100 different tires, and the average, let's say the average for Talon's tires, if you actually had to measure it, if you had to take every single tire in Talon samples, 100 tires, you add them up and you divide by 100, you would get an average. So you would get an average of, let's say, 50,100. Okay. If you do the same thing for mine, you take all 100 tires in my sample, right, and you averaged it. If you averaged it and you got a value of, let's say, 50,120, right, and same for person C, right? You're getting the idea here. That person's average was, let's say, 49,900. Okay, the thing is, we're not interested in the exact amount, okay? And there's a reason why we wouldn't be interested in the exact amount. We want to know the probability of these averages being greater than something. Why is that important? Because in practice, you can't draw every single sample of 100. This is just impractical. I just showed you 3 people here. Right? There's no way you could. Let's say we had to draw 50,000 samples. So we need 50,000 people here to draw these samples. It's not practical. You can't do this. Okay, it's financially it's not possible, and time-wise it's not possible. If we could do that, we could get the average of each one, but it's just not practical. So what we do is we use statistics. We use what we did here on the right. We just want to know what's the chance of the sample average being greater than 50,000, because that probability is important. So think about it this way, right? We want to know the lifespan of a tire, right? If we can show that the average has a very good chance of lasting more than, say, 60,000 miles, if it has a very good chance of lasting more than 60,000 miles, so it doesn't matter what sample we draw. If we say whatever sample we draw, irrespective of who draws it, but as long as the sample size is 100, if the chance of those tires lasting more than 50,200 has a high probability, then it's not a bad tire, because we want the tire lifespan to last long. In our case, if you look at it, it has a very small probability. 0.62 is quite small. I don't know about you, but if someone tells me you have a 0.62% chance of your tires lasting more than a year, I wouldn't buy those tires. Okay, I'd want like 80%. You need to give me a stronger chance. So that's why the probability is important. Okay, because we want to certain that it has a high chance that it will last past a certain mileage. In our case, the mileage that they're asking for is 50,200. All right. Okay. But just ask away, please. I'm assuming everything's okay so far. All right. So now what I've showed you is how to solve, to work out the probability of a sample mean. Okay, so far we've only been working with averages, right? So let me clear the board. And now we're going to deal with the question on the right, the box on the right, okay? And that is in terms of proportions. Okay, so let's clear this up and put things into context here. Okay, so what I've just shown you, okay, the last part of what I've just shown you is I've showed you that if you're given the sample mean, okay, if you're given the sample mean, X bar, okay, right, it follows a normal distribution, okay, the center of that distribution is mu. If we want to work out probabilities of X bar, we need to convert it to a Z. So we use this formula here to convert it to a Z. X bar minus mu all over sigma of the square root n. Right? We use this formula here. Right? And that will convert it to Z. And then once you've got your Z value, you can find the probability using the table in the back of your book. Now we have a curve in terms of Z. Right? And so it's important that we know how to go from X bar to Z, all right, using this formula. Now, instead of averages, because X bar is an average, instead of an average, you can be presented with a proportion. That means, a percentage of people. So for instance, percentage of people that smoke, percentage of people that are, percentage of people that drink, percentage of people that gamble. Okay, it's not an average, it's a percent, right? So you can get a percent of people, proportion of people that, you know, what do you call it? Do an activity and the proportion that don't. Okay, so think of the amount of people that default on their loan. So let's say people that take on car loans. Let's say 12% of people don't pay back their car loans. Okay, that means the remaining percent, 88% of them, do pay back. Right, so that's not an average, it's a percent. So instead of X bar, now we're dealing with proportions, and we'll write proportion mathematically with a P. Okay, now the proportion can also follow a normal distribution. Okay, so here, and where it's centered, okay, would be the true proportion. What do I mean by true proportion? Well, look at it this way. If we're looking at the more percentage of people that smoke in South Africa, okay, so South Africa, this is South Africa, quite big, and the true proportion of people that smoke, right, let's say is 20%. Okay, so your pi is 20%, right? So that means so we have to look at every single person in South Africa, every person, we don't miss anyone, and we determine how many of them smoke, all right? Then all we need to do is work out that fraction. Okay, the number of people that smoke divided by the total population is 20%. That's the true percentage of people that smoke. Okay, that's your pi. However, if we draw a sample, so if we go to just KZN, right, and we just look at a small sample, we're looking at KZN over the entire country. Okay, if we just look at KZN, KZN would have their own percentage of people that smoke. Now that percentage, that proportion is P. That's the sample. Okay, because it's only KZN, it's not South Africa, it's not the true proportion. It's a sample of South Africa. So we took a sample of South Africa, and that proportion of smokers we would represent with P. So that's the difference between P and pi. Okay, so P is the sample proportion and pi is the true proportion. Just like how mu is the average of the entire population, X bar is just a sample. So mu is your, for this example we did earlier, that's the average of all the tires made by the manufacturer, the entire factory. X bar is just a sample that you took. It's just a sample of 100 in that example, in the example we did last. Okay. Now, we could be asked, what is the probability, right, P, of the sample proportion, this P here, right? What's the probability that P is greater than something or less than something, right? It could be 10%, 20%, etc., right? Now, in order to work this out, we would have to convert this to a Z value and use the table in the back of our book. And how we convert this to Z is by using this formula. You don't have to memorize it. It's given to you in your formula sheet. So it's Z equals P minus pi all over square root I into 1 minus pi all over n. Everything in its denominator is under the square root sign. Okay, I know it's a big formula. I understand that, but yeah, unfortunately, that is the formula. Okay, so you need to become familiar with how to use it. So that's how you go from P to Z, and then you back to using your Z distribution at the back of your book to solve it. So let's do an example to kind of show you how to use it, right? So let's sketch this part here. Now we're back to our Z distribution that's centered at 0. I'm going to clear the stuff on the left. I'm going to use the space. And we're going to work with the problem on the right, okay, the top right box. Okay, so drawing your attention to this box here. Okay, so maybe I'll just erase this so you can Let's focus on that one. Okay. In a certain neighborhood, it is known that 12% of school leavers are unemployed. So that 12%, that's your pie. That's your true proportion. Okay. Because it wasn't measured by taking a sample. It's telling you the entire neighborhood, it's known that 12% of them are unemployed. So that's your pie. The pie is 12%. Right? If a random sample of 150 school leavers, now I encourage you to try and determine what symbol does the 150 represent. Okay, what do you think the symbol is for that 150? Maybe write it in the chat. Okay, this is important because you're going to have to answer this question, come exam time. So it's important that you try and, make an attempt now. So the question says, if a random sample of 150 school leavers is selected, okay, so I want you to tell me what symbol is used to represent the 150. Okay, so we got a sample of 150. What is the probability that the sample contains less than 15%? Let me just check the chat if anyone made an attempt. Give it a shot, people. Give it a shot. Please. Good attempt, Tim. Good. No, but okay. The answer is N. Okay, just keep in mind, N is your sample size. It's what you count. Okay, it's how many people are in the sample. So this KZN example, right? The amount of people that you have in the amount of people that you have in KZN, that's your N. In this question, you have 150 school leavers that they selected. Okay, so they went to a school. Sorry, in the neighborhood, they sampled only 150 of them. So think now, instead of South Africa, like what we were talking about, they were talking about a neighborhood where the pie is 12%. 12%. Right? That's the neighborhood. Now there's a sample of school leavers. There's 150 of them. There's 150 of them. That means that's your N. That's your sample size. All right? That's your sample size. Now, P, you don't know. Okay, you don't know the exact value of P, but you're not interested in the exact value of P. You're interested in working out the probability of this P. P is a variable, right? Now, what they're asking you to work out is, what is the probability that the sample contains less than 15% unemployed people? So before, I used smokers as an example, right? But now we're not talking about smoking. Now we're talking about the percent of people that are unemployed. So the percent of people that are unemployed in the population, right, the neighborhood, is pi, and that's 12%. They're asking us to work out what is the probability that the sample has less than 15% unemployed people. So what they're asking us is to find what is the probability of P less than 15%. That's what we're asked to work out. Okay, this is what we need to answer. Okay, that's what this question is asking us. So what do we need to do? We need to convert P to Z. Okay, and we need to use this formula here to do it. Okay, so we're going to use that formula. And so remember now you have 15%. Right? So there's your pi. Pi is the center. Pi is 12%. So there's your center. It's 12%. Okay. So 15% is greater than 12%. And that's here. It's on your right. Okay. 15% is there. And they want us to work out what is the probability that P is less than 15%. So that means you need to work out the entire area. Less than 15% means everything that's less than that value. So you need to work at the entire area here. Okay. So this area here, which I'm shading in black, and I'll shade the other half of the area in blue. Okay, if you work out both these areas, that's the answer. Okay, you need to work out the blue area and the black area and add them up, because that's the total area for everything that's less than 15%. Okay, all right. So what do we need to do? We need to convert this 15% to a Z value and find out what is the equivalent Z value here. And how we do that is we use this formula here. And so I'll rewrite that formula. It's Z equals P minus pi all over square root pi into 1 minus pi all over n. Okay, so we're going to work out that Z value. For P, what you substitute for that is this value here, 15%, whatever you're interested in, that's what you're going to substitute for P. Okay, so that's your P value, 15%. Your pi is 12%. Your N, we've already showed you what that is, it's 150. Okay, so you substitute all those values into this equation, and you'll get a Z value of 1.11. 1.11. So this value here, this equivalent Z value here is 1.11. All right, and so we need to work out the area on the left of 1.11 for the Z curve. So we need to work out this area here in black. This you can get from your table. The blue area is very easy. Remember, everything on the left of 0 is 50%, because your graph splits the area up into 50% for everything on the left of 0 and 50% for everything on the right of 0. It's symmetric. Okay, so remember we did that in the last session. So this blue area, you don't even have to look at your book. This blue area is easy because it's everything on the left of 0. It's half this graph. So that's just 50%. Okay, and the black area is what you're going to use the table in the back of your book for. And if you use your table, you'll see that the area is 36.65%. So your final answer, okay, your final answer, okay, this becomes probability of Z less than 1.11. That is 86.65%. That's the final answer. Okay. All right, everyone. That's what I wanted to cover this evening. Any questions? You've been very quiet, so the floor is yours now. Please ask away. Thanks, Vanessa. Ken, go for it. Shoot. I think you raised your hand. I'm not sure if you were clapping or you want to raise your hand, but go for it. Ask away. No problem. No worries. Yeah, so I did say, yeah, you need to have a good understanding of last week's session. I told you that normal distribution carries over. So you will use it not just in Learning Unit 7, you're also going to use it in Learning Unit 8. So please practice with that. Make sure you understand how to find probabilities of Z and how to convert variables to Z. So I'll just do a quick summary recap here of the main ideas of what I want you to take away from this session. All right, so I figured out that probability turns out. Good, glad to hear, Vanessa. All right, so let me see what it summarizes, right? So I'm going to type instead this time. I'm sure you'd prefer that instead of my writing. So first point is identify. First thing you want to do is, let's get my keyboard out. Okay, you want to identify if you are dealing with three things. Okay, one of three things. If you are dealing with a single unit, right? The single unit, which is X, or are you dealing with the sample mean, which is X bar, or are you dealing with the proportion? Or proportion P. Okay. Okay. First step is identify if you're dealing with these three things. Are you dealing with the single unit X? Are you dealing with the mean, the sample mean X bar, or are you dealing with proportion? Depending on which one you're dealing with, that will determine which formula you need to use to get the Z value. So for X, remember for X, you would use the formula, if you had X, then to get the Z value, you would use Z equals X minus mu all over sigma. All right, that's what we did last week. This week, if you're dealing with X bar, the second part, then to get your Z, it's X bar minus mu all over sigma over square root n. Okay, if you're dealing with proportion, the last one, okay, then use this formula. P minus pi all over square root pi into 1 minus pi all over n. So you don't need to memorize any of these formulas that is wrote. They're in your formula sheet, but you just need to know when to use them. All right, so for statement one, as soon as you know which one you're dealing with, then that'll determine which formula you use. So step two is to use the appropriate formula that I just showed you here. And once you've got the Z value you need, the last step is to calculate the probabilities using the table in the back of your book. So here, you calculate the probabilities. Using the standard normal table at the back of your textbook, right? Or it'll be when you're writing an exam, they'll give you the table printed out. Okay, you won't have your textbook with you. That's the three steps, the three main points I want you to try and focus on at a high level of what the session covers, right? All right, okay. One more thing I just want to point out to you. Sometimes you can get asked to determine the standard error. Okay. All you need to know about the standard error, it's very simple. Okay. If you're asked to calculate the standard error is whatever is in the denominator of these formulas. Okay. So for instance, if you were dealing with the sample mean, right? So option 2 here, if you're dealing with the sample mean, your standard error is whatever is in the denominator of that formula. This is your standard error. Okay. If you're dealing with proportion, that is option 3 here, this one here. If you're dealing with proportion, the third formula, then your standard error is whatever's in the denominator, which is this entire thing here. That's your standard error. That's as simple as it is. Okay, that's your standard error. That's the denominator. So the standard error is the denominator. All right. Oh, where's Oh, whoops. Okay, that is it for me, everyone. Any questions? Remember, even if you don't have any now, you can always ask me by email. But the floor is yours if you want to ask away. Well, other than that, that is it for me. And thank you for joining. I hope this session helped, and I'll make the recording available as usual. No problem. All right, everyone. Have a good evening.